Hi guys, it's Miss Leslie, and I'm coming to you with this video because I think this particular problem is giving you guys a lot of headache. And you know guys, I want this to be an experience that is going to be enriching but not a headache for you. So I'm going to work out this problem. This problem is from one of the lessons on equations that you are supposed to complete before Monday at 6 o'clock, okay? So I'm going to work out this problem for you. We're going to take it step by step. I would like for you guys to join me, which means right now, I want you to go and get a piece of paper and a pencil and work out this problem with me as I go. And then maybe you can find out where you made your mistake, okay? I'm going to go on and give you a hint. I worked this problem out twice. I worked it out late one night, maybe a night or two ago, and then I worked it out again this morning, and even I got the wrong answer. So I want to make sure, guys, that we are taking this step by step, and we know what exactly the steps that we're supposed to take to go about solving this problem, okay? Are we ready? All right. Guys, just like always, whenever I'm solving an equation, some of you told me that this has helped you out a lot, so I'm going to continue to do this. I'm going to look at the equation, and I'm going to draw a line down the middle of the equal to sign, and that helps separate one side of the equation from the other, okay? And when it's separated like that, it also helps us to know what it is that we need to take care of first, okay? So when I look at this side of the equal to sign, guys, remember that we've been talking about distributing, and we've been talking about collecting or combining like terms together. I know that the first thing that jumps out at you is that you have two x's on this side of the equal to sign. You've got this 1/4 x and this negative 3/2 x that we can combine together, okay? The problem with us trying to combine these together is that you cannot add or subtract fractions together unless they have the same denominator. So what you have to do is go back to 6th grade and do a little 6th grade work and make sure that before you try to combine these two together that you make the denominators the same, okay? So guys, I got this piece of green paper over here where I'm going to show that I'm working out and making the denominators the same before we go on, okay? So I've got 1/4, and I'm just going to ignore the x for right now and come back to it. And then I've got negative 3/2. Okay? Guys, remember that when you're trying to make denominators the same, you always want to go with the denominator that has the biggest number in the bottom. Okay? So you got fourths and you got seconds. Okay? 4 is bigger than 2. So I think it's better that we take negative 3/2 and turn it into fourths. Okay, so I'm going to go in and write that 1/4 is going to be 1/4 in the end, but negative 3/2 I want to turn into fourths. Okay, I do not know, guys, how your math teacher taught you how to change convert fractions from one unit of measurement to the other, but I'm going to show you how you should do it. Okay, what you need to think about is what number times 2 will give you 4. That number is 2. 2 times 2 will give you 4, right? So whatever we do to the denominator, we then have to do to the numerator. So again, I'm going to multiply the numerator by 2. And a negative times a positive is a negative. And 3 times 2 is 6. So guys, what used to be negative 3/2 is now negative 6/4. And since the denominators are the same, I can combine them together. So let's go back over here to the white paper and let's rewrite our equation as 1/4 x, which we kept, the 1/4 from before. And what used to be negative 3/2 x is now negative 6/4 x. Then plus 12 equals 2/8 x minus 3. We know everything else is going to stay the same. Okay? Now that these are truly like terms, 1/4 x and negative 6/4 x. We can combine them together. 1/4 x minus 6/4 x will give me negative 5/4 x. Plus 12 equals 2/8 x minus 3. Okay? Guys, this would be the point when we were talking about one solution, no solution, and infinitely many solutions before, where we would look at both sides of the equal to sign and compare. We would see if the coefficients were the same and if the constants were the same. Okay? So when I compare coefficients and constants, they're both different. So we already know without having to do any math whatsoever that this equation has one solution. But I believe this particular problem asks you to find out what the one solution is. So we have to continue to work to figure out what x actually equals. Okay? So what we have to make sure that we remember is that we want all x's over here on this side and all constants or numbers over here on this side. All right. So if I want all x's over here, the negative 5/4 x is going to be able to stay, but the 2/8 x that's over on this side needs to be moved over here. Okay? The opposite of positive 2/8 x is negative 2/8 x. We remember that what we do to one side of the equal to sign, we have to then do to the other side. So I'm going to subtract 2/8 x from this side as well. Now, on this side of the equal to sign, the 2/8 x are going to cancel out, and there's nothing left over on this side except for negative 3. And on this side, we're in the same predicament as we were in before. I want to combine these two fractions together, but I can't because the denominators aren't the same. You can only add and subtract fractions together when they have like denominators. So let's go back over to the green paper and let's figure out which fraction is better to convert. I've got negative 5/4. I'm going to leave the x off for now. And I've got negative 2/8. I'm going to leave the x off for now. So let's compare. I've got 4 and 8. Remember, you always want to go with the bigger one. 8 is bigger than 4, so we're going to take negative 2/8 and keep it as negative 2/8, but we're going to take negative 5/4 and convert it into eighths. What number can we multiply by 4 to get 8? That number is, 2. And then whatever we do to the bottom, we do to the top. So we'll multiply negative 5 times 2 as well. Be careful with your signs. A negative times a positive is a negative. And 5 times 2 is 10. Okay? So guys, when we go back over here and compare, negative 2/8 x stays as negative 2/8 x. But what used to be negative 5/4 x is now going to be negative 10/8 x. Because remember, we changed negative 5/4 x into negative 10/8 x. Okay? Alrighty. Now we can combine like terms. Negative 10/8 x minus 2/8 x will give me negative 12/8 x. And there's my negative 3 that I brought down from before. And here's my 12 that I'm also bringing down, my positive 12. Okay? Get to this point, guys, you should recognize this as a two-step equation. Remember that when you have a two-step equation, you always get rid of the number that's on the same side as the variable, but that is the furthest away. And we talked about up here in this step that we wanted all the x's on this side, which we accomplished. And now we want all the numbers on this side. So that means that I'm going to have to get rid of this positive 12 by doing the inverse. We'll do the opposite. The opposite of positive 12 is negative 12. And what you do to one side of the equal to sign, you do to the other. 12s cancel out, and you'll have negative 12 eighths x equals negative 15. Watch your signs, watch your signs, watch your signs. Okay, guys, I already know at this point you recognize this as a one-step multiplication equation. You know why I know that you know that? Because you have a number and its variable side by side. Even though there's a fraction bar in there that hints to division, we know that whenever you have a number that comes directly in front of the variable, that means you're multiplying the two of them. So what we would have to do is the opposite. What's the opposite of multiplication? Division. We're supposed to divide both sides of the equals to sign by negative 12 eighths so that x can be alone. So I'm going to divide this side by negative 12 eighths and this side by negative 12 eighths. Okay? Guys, again, we're in some trouble because if you don't remember how to divide fractions and whole numbers, you won't be able to get what the correct answer is in the end. So let's go back over to the green paper one more time, and let's divide negative 15 by negative 12 eighths. Okay, I've got negative 15 being divided by negative 12 eighths. All right. So guys, do you remember how to take a fraction or two fractions or a whole number in a fraction and divide them? You guys remember KFC? Not the chicken, but keep flip change. Okay? The K in KFC you do to the first term. The F means that you take it and flip it, and then the C means that you would change this. Okay? So first thing, guys, I need to make sure that we recognize is that negative 15 is not a fraction. We're going to keep it the way that it is, but we need it to be in fraction format. So in order to make it a fraction, I'm going to put it over 1. See, now it's a fraction. Then for flip, that means that you take the divisor 2 bar and you flip it from division to multiplication. And then the C stands for change, which means you would take negative 12 eighths and you would change it by taking its reciprocal, and it's going to be negative 8 over 12. Okay? This is the time, guys, where it could help you if you had your little calculator. I'm going to use my calculator. You guys are at home. You're doing this at home. You can do this on a calculator. Let's multiply. 15 times 8 will get 120. And will it be positive 120 or negative 120? A negative times a negative is a positive 120. Divided by 1 times 12, which is 12. Can you simplify 120 over 12? Yes, you can. You can divide 120 by 12. How many times? 10. 10 times. You guys don't believe me. Let's do it. Here's 120 divided by 12 equals 10. See? All right, guys. Finally, we have arrived to the correct answer, where x equals positive 10. Hard problem. Well, not so much a hard problem, more so of a challenging problem. But guys, I really believe that we could have cut out a lot of steps if we dealt with decimals, but sometimes decimals are repeating and decimals come out and on your calculator and they've been rounded. So that's why I would have rather you took the steps, to convert your fractions, to make them the same, and then what you did in 6th grade by taking these fractions and dividing them and doing all that stuff from before. So guys, you can see that these objectives from the previous years, they build on each other. So you can't just get the stuff and forget it and never look at it again. You got to make sure that you master these concepts and practice them, as you can see throughout the year. But I think, guys, this was one of the hardest problems. So if you got this problem wrong in the lesson, send me a message and I'm going to resend the lesson to you so that you can get it right now, especially if you worked it out with me, okay? And guys, if you have any additional questions about any of the other problems, please just message me and I'll help you as best as I can. Guys, please remember that I need all of the lessons from this particular lesson by Monday at 6 o'clock. So on Tuesday, we can start talking about volume. All right, guys, have a wonderful weekend.